Does anyone have a charger for like an old iPad or old iPhone? You know, the old school charger? I don't know if I brought mine. Does anyone have it and they're not going to tell me, so they're hoping my thing runs out of power? Oh, I don't know. I'll keep looking. I believe I can get you started, and then we'll come back to it. This is the deal. Watch and get pumped. Yes, we are still recording. Hi, friends on the internet. How are you? Haven't spoken to you in a while. Thanks for following my Twitter feed.
Your Twitter feed?
Oh, yeah.
Are you sure?
I'm sure.
Should I follow you?
Yes, and you know what it has on there? It's really cool. Videos. The only thing that I post to Twitter are all these videos that go to YouTube. I automatically link my YouTube to my Twitter feed, and that's all I have. So every video I've made is on my Twitter account. Isn't that nerdy?
Only a little bit.
Only a little bit. That's all I got going for me. Okay, we should start with purple. Ladies and gentlemen, you believe it or not, this is part A. This is what this is asking you. It says, find the volume of the solid whose base is bounded by the said graphs with the following cross sections taken perpendicular to the x-axis. What are you talking about? There we go. Let's describe what I'm talking about. And then let's get the Play-Doh out. Okay. We have things to do. We have very serious things to do. Okay. Let us continue. I've been working with the FLARP. You guys got the single finger FLARP is really helping. Yep. Hang on, I'm still recording, but just one good FLARP for all of you. I'm gonna let Ross play with it in a minute because you can tell he's that kind of guy. He's a FLARPer. Okay. Watch this structure. Uh-oh. What is he doing? Okay.
Whoa.
There is a square solid of dx thickness. That's like a book, a square book that I just put on that happens to be the same width as the distance between those two curves. If you can't see where it's, some of you think it's going into the screen and some of you think it's coming out of the screen. It's hard perspective. See that corner? I just highlighted that corner. That's coming off the page. I want you to think Google Earth. So Google Earth, you're looking down at houses. You know how Google Earth gives you that little tilt now? So that you kind of see the sides of buildings? Have you looked at Google Earth lately? But this is like a square building coming off the map.
Okay.
It's coming off the map.
Okay.
Next to it, since you are so adamant about this, Tyler B., that I bring in one more book. Pink. Per
Is it
your.
a square?
Oh, yeah.
So we're doing A.
Oh, yeah.
Okay.
Can you see the pink book next to the purple book?
Wow, that is really.
Okay. This is the next part. What color do you want for the next book? Blue. Okay. Blue book. Now, this one's a little shorter than the others because it's a smaller span. But the thing is my cross-sectional slices are the same height as they are wide. So if I make it not as wide, I also have to make it accordingly not as tall. There's a blue book next to the pink book, next to the purple book, all coming off the page. It's like skyscraper buildings next to each other, or like row houses in San Francisco. Sit next to each other, you know what I'm saying? So we gotta let's put some yellow. One more. The yellow's fun, really stands out. As they say in the design shows, it gives it some pop. You noticed that lately? It's like the word. The design word is it pops. There you go. There's a yellow book next to the blue book, next to the pink book, next to the purple book. They're getting shorter. They're descending into a deep sleep. Like, we're losing you, Garrett. Man, we got you back. We got him. We got him. Tamales. Hot tamales. Come get some hot tamales. But they're getting shorter because the width is also getting smaller. And they're as high as they are wide.
So coming off the page, is that their height?
The height
Yeah.
off the page is the same as the width from x minus 1, the top function, to the lower function. I've sliced them and I put them across there. Is that cool? Are you digging this? You showing?
I
Okay.
don't know yet. Find out.
Okay. I'm going to fill this baby up with multicolor. We can put some more books. Let's go orange. Did you guys ever go through the phase we called it orange? You couldn't say it right? No. Dang it. That's why you guys are in this class. And I didn't qualify. There's the orange one. I struggled to do the orange one. Looks a little more like peanut butter. Did we do green yet? Okay. Little stumpy short book. Short book. Okay. That one's coming off the page too. So look at those descend. Now we have to do the other side. So what does this create? It creates a particular volume. It's coming off the page. It kind of curves the same way that it widens. So here's the funny part. If you were to look at it, let's say this is coming off the page. You looked at it coming up from the south. Let's say this is north, going up like that. You're looking up toward it from that side. You're going to see these books climbing in the same shape as the curve as it's laid across. It's going to have that same, this is going to have the same look as the shape that we designed over it. So it's going to look kind of like that when you get done designing it. Isn't that crazy? Your sideways view is going to look the same as your front view because the heights are created the same way as the depths were. Isn't that neato? So we need an actual image. By the way, we can get the volume of this because every one of those squares is created from the same volume formula. So let's create one of them and then we just integrate it. One little rectangle. Shall we do the purple? Because we are Waukee. Purple. Purple. Here's exaggerated purple. The width of this thing is x plus 1 minus the bottom function, which is x squared minus 1, right? That's that one. And then the other dimension, the same. It's a square. Okay. So look at the width and the height. They're both the same. The volume of that rectangle, a rectangular prism, square prism I should call it, is actually, since the sides are the same, would you mind if I were to do x plus 1 minus, to make this bigger, x squared minus 1, quantity squared, because it's side times side. Remember? Side times side times side. The length times width times height. This is my height. There's my depth right there. If I can create the volume of one of the shapes, an integral on the appropriate interval, which for us is from -1 to, when do they intersect again? Is that 2? 2 squared, 2 plus 1 is 2, 2 squared minus 1 is 4, minus 1 is, that's right, 3 and 3, so that's 2. So it's -1 to 2. The volume of whatever this thing is that we just created, you just take the shape that you're iterating, its volume, and integrate it on the appropriate interval. If you look at what I was talking about before, just to kind of bring it all together, remember this is the area of the face, and this is its depth. and our face was a square with sides x plus 1 minus x squared minus 1 quantities. Whew. It is time to play, and I'm going to stop the recording. That's good. That was a good length.